Hi, good morning. Well, today we will try to see about the analysis of hydroclimatic data by using Python. It will be a long journey, so today's lesson will be the first part, and then we'll go through different topics related to climate and streamflow data analysis using Python. So, as all of we know that Python is well-known programming language nowadays, which is an interpreted language. So, if you will see here, as of 2026, on the top 10 programming languages by popularity, Python was recognized as first. So nowadays, many data analysis and manipulations has been done by using Python programming, as it is easy than the others, and also many applications and packages are already incorporated within this programming language. So we will try to see how we can analyze the data in CSV as well as in NetCDF in Python. So the first one will be the foundation environmental setup. That means how we set our environment within the Python working environment. What I mean is there are different Python working environments that we can try to write and edit codes. So there is a Jupytor Notebook, Jupytor Lab, and also you can do different Visual Basics and the like can be used for writing different codes using Python. So for now, our learning objective will be how we set up the professional Python environment for hydrological and climate data analysis. And we'll try to understand the key Python library packages that can be used in water science and climate research. And also, we'll try to load and display common data formats, CSV, comma separated, or NetCDF files, or Excel, or JSON files, spatial data analysis, and connect to freely available climate and hydrological datasets. So these are the main objectives that we will try to see in the future. So basically, Python libraries for hydroclimate data science are not only this, but these are the main ones. So you will use Pandas in order to analyze and manipulate tabular data. For example, you may have data within Excel or in CSV files. You will use Pandas to import the data and analyze using this package or library. And also, you can install this Pandas package or library by using pip install pandas. This is basically can be used to write on the shell, but if you are writing on if you are trying to install on the Jupytor Notebook, you may add % in front of pip. We'll see how we can do that. The other library is NumPy in order to analyze numerical manipulations and computations, and also in order to produce random array data or in order to operate different array. And also the installation is the same, but the library is different. The other one is matplotlib or seaborn. These are basically used to visualize the data. In order to see the data in graph or in maps, you may use or plot by using matplotlib or seaborn. So statistical visualization plotting can be done by using this too. So the other one is SciPy. It can be used for signal processing and statistical testing. Xarray, in order to import and analyze the multi-dimensional arrays of data. For example, NetCDF, grid data nowadays are common. So how we are analyzing the multi-dimensional data, the data that comprises or contains different variables. In a single NetCDF file, you may get temperature, precipitation, sunshine hour with a fixed time interval, as well as different latitude and longitudes. So in order to analyze such kinds of data, you may use Xarray, NetCDF, which is basically used to read or write NetCDF files, Hydro-Eval, this is basically used for validation. In order to validate the performance of your model with the in situ or the observed data, you may use master frequency or Vinjekuta or KGE. Model performance metrics can be analyzed, and you can make a decision based on the analysis that you have made by using Hydro-Eval. The other one is scikit-learn. If we are doing machine learning algorithms, you may use scikit-learn, TensorFlow, further deep down in deep learning, like LSTM and neural network CNN. Maybe use TensorFlow for deep learning analysis. In order to analyze the trained, you may use a Mankindle train test. So the package of the library is PyMankindle, which basically do the Mankindle train test for different climatic and hydrological data. GeoPandas, basically used for analysis of spatial data, which can be used in GIS data processing, can be used to analyze by using GeoPandas. The other one is Xarray, which is combination of raster plus Xarray integrations, can be analyzed. So, as all of you know that there are different sources of data that you can obtain from satellites. So, the key open data source might be NOAA, which is the Global Historical Climate Network. Station weather can be obtained from this. You can access the data by using this URL. The other one is Era of Life, which is European ESMF pre-analysis data, which is gridded format, and also you can get it from Copernicus data portal by using this accessing URL. Chirpus, which is one of the well-known data source for Ethiopia, for example, rainfall analysis can be done, especially for monthly rainfall data analysis. Chirpus is well suited. So you can find the satellite precipitation data from this URL. The other one is USGS stream stars or water data. The Streamflow with discharge can be obtained from this platform. And also you can get global runoff data center, GRDC, river discharge. World Clean is version 2, historical climate normals. And also if you want to get the future climate scenarios, which is well known for future climate impact analysis, same IP6 climate projections can be obtained from this URL. So these are the data sources that you can obtain the data. Now let's get directly into the work for Jupytor Notebook. This is the Jupytor Notebook interface. So for now I want to show you how to do different things from Jupytor Notebook. So this is the part 1 for processing and visualizing the data from CSV file or from NetCDF files with the multi-dimensional array. So here you can see untitled. So we can say tutorial. Let me say rainfall data analysis part 1. I can rename it. So you can see this is basically the tutorial for rainfall data analysis. So I'll write the code here. As you can see here, it says code. If you drop down or if you click the arrow here, you will see different options. If you make it markdown, it will be put as a comment or as some kind of text. For example, I'm making markdown and I am specifying hydro in the right. If I am running this code, it will be simply seen as a text. So in order to write the code, you have to make it as code. So now first you have to install the libraries, the necessary libraries that you want. For example, if I want to install the library pandas, %pip install pandas. Since I have already installed it, I don't need to install it, but if you are new and fresh to do this, you can use any libraries instead of pandas and you can install it. So in order to run it, you may click this one, run this cell in advance, or shift plus enter. So now you can see the asterisk here, that means it is working, and you can see here this symbol which is showing us this code is running. So while this code is running, it is basically tries to install different pandas, different contents within the pandas library. So you have to wait for some time. So you can see the requirement is satisfied and it is basically installed. So as the index says, you may need to restart the kernel to use the updated package, right? So here you have a kernel, click on it and restart kernel. That means the updates package will be involved or included within your code. Well, after installing, you may install different libraries. So since I have already installed, I don't need to do that. So now, shift plus hashtag is basically show us how we can write comment. So this is commenting, right? So import the necessary package, or let me say libraries or core packages. Let me see. Core package. Enter. Now import pandas as PD, since it is recognizing it simply simplifies your work. You can use pandas as it is, the longer name, but to work on it, it may be takes longer time to write on it. So you have to use your own short form, but the way recognizable is PD. The other one is import NumPy as NP, right? Now we are importing the data. So importing the library, sorry. Now let's bring or import the CSV file, which is the rainfall data in my case. In order to do that, let me give the name df, which is the data frame, pd dot read underscore CSV, then open bracket, and you have to put the path where the data is found. In my case, I have rainfall data for Addis Ababa, which is found within this folder. So since it is a backslash here, since it's a backslash, you have to put R in order to reverse that, unless it's not recognized or read by your Python. Or you can use double slash here instead of R at every point, or you can use forward slash. For now, let me say this is enough. So I have to close the bracket, then enter. In order to see what's in the data, df run the code. So now it is running the code that I have written so far. which is basically tries to import the CSV file or the rainfall data from the path where it is already found. So wait for some time. So you can see here, it basically shows me the index values, the date, day, months, and year, and PCP means precipitation in short form. I have 14,975 rows and 2 columns, right? So every data here is basically collapse the output, since it's, as you can see, 40,000 is very large number of data, so it can confine it. But most of the time you may write print DF. That's the formal way. In both ways you may get the same result. So in order to see the top or the head only, you can say print df dot head, then run the code. By default it will show you 5 of the top values of the precipitation within the data frame. Or you can limit, for example, print df dot head 10 rows. I want 10 rows of the data. So you can see from 0 up to 9, which is 10 rows of the data can be displayed, right? Or you can print df dot tail, the bottom part of the data can be displayed here from 14,974 to upward. You can see the bottom lines of the data. Or even you can restrict this one by saying print df dot tail, let me say again 10 of the bottom lines, and run it, and you can see 10 of the time series data at the bottom, or at the end, from the end of the date or the gap that you have already specified. The other thing is print df.info. Can be another code that you can run in order to see what's going on within it. So it is basically having 40,975 entries where the index starts from 0 up to 40,974. And also in the column you may get date and PCP, and here 14,877 data are non-null. That means the data is available, the rest is missing data, right? The total data is 40,975. From this you can subtract this and you will get the missing data. This type is float, and it's the memory usage and the likes can be displayed while you are saying df.info. And the other command is print df.describe, right? And you will see the statistical measures of the data. That means the count of the values, how many data are basically found at the PCP, which is not counting the non-available data, right? The mean, the standard deviation, the minimum, the first quartile, that means 5%, the second quartile or the median, 50%, and the third quartile, and the maximum value. All these parameters are basically found for the precipitation data that you can see within the CSV file, right? You can describe in this way, or you can basically know the missing data. For example, print df dot is null, and run the data. This code basically is doing that. It says false. It runs for the date and the precipitation for both. So when it says false, that means there is no null data, or there is no unavailable data. The data is available. If it is true, it's a missing data, right? So rather than visualizing this way, it's better to write print, right? Print df dot is null dot sum. That's better, right? If you run the code, you can see the missing data within the precipitation column is 98, right? And the date column, there is no missing data. It's simply a date and no missing data. The data type is integer at 64, right? So this is how you can see what your data looks like. Or in other words, what we can do is let's index the index is this numbers, which is basically found from 0 to 4974. I want to make date an index, so let me create another data frame. df1 is equals to pd dot read CSV, right, and comma parse dates equals to date column, comma index column equals to date, right? So now what I do is I have changed the index column as date, right? As date. So enter print what? df1. Then run the code. And you see that here the index is date and the value can be the precipitation. Then this column is now removed and the index is the date. So you can index your data as this. Or let me say df1 dot plot. In this case, import matplotlib as PLT. Right? Well, you can see it's rough graph plotting of the data. Here is the precipitation with time, right? The precipitation with time. And we will see in the future how we can plot very refined graph by using matplotlib. And the other data is an NetCDF data. So let me import Xarray as XR. Then let's say the dataset is equals to XR dot open dataset, right? Then let me bring the sample data, which is this is the rainfall data from enact in NetCDF file, copy as path.nc file. So now plus V, and here I have to reverse it. Then print yes, then run. Well, now we are importing the Xarray library, and we'll try to see the NetCDF data, which is basically the rainfall data from 1981 up to 2018, which is from Ethiopian Meteorological Agency, the enhanced data, which is enact data, which is the merged data from satellite rainfall with the observed or the measured data. Based on your computer, it will be faster or slower. Since I have so many things in my computer is very slow. Well, you can see this is the data having the size of 7 gigabytes, huge data, with the dimensions of time, latitude and longitude. So you have time, latitude and longitude, and the variable is precipitation, which is written as a short form precip, right? Precip. The attributes are already found here: climate data interface version and convention history and the likes. So you can see so many things here, right? You can see so many things about the data. Now within this dataset of the NetCDF, you have the variable precip. Let me select and copy this control C. Then here in the new cell, what you can do is ds what precip. In order to visualize, let me say print. No, let me say here rainfall is equals to ds precip print rainfall, right? Now I can run the code. Now you can see here. You can see it is an array data of precipitation with coordinates as time, latitude, longitude. The longer name, this is the merged satellite rainfall, and the unit is in millimeter, right? The unit is in millimeter. So you can see and import the data. In the future, in the part 2, we will see how we can analyze the missing data and filling the missing data, and then we'll see how we can use the data in order to analyze different data manipulation in hydrology. Goodbye for today. That's all. Thank you.